Chapter 22, page 620, question number 43. Researchers, comparing the effectiveness of two medications, randomly selected people, made the people divide into two groups, Group A getting a different pain medication than Group B. This is just summed down, written differently in my words of the question. So this is what they gave us. Group A had 112 people in the group. 84 said the pain reliever was effective. So before we talk about Group B, we'll do the confidence interval for Group A. So, the formula for confidence intervals is p hat plus or minus z-score under the square root of p hat times q hat over n. So, you have to know what the variables stand for. So, p hat, we'll talk about that down here in a second. Z, in this case, is 1.96 because you're doing a 95% confidence interval, so your z-score is always going to be not 1.96 when you're doing 95% confidence intervals. So your p hat is just, so what did we say the numbers were? 84 over 112. That is equal to 0.75, and that is going to be your p hat. Now your q hat is the rest of the people that disagreed about the pain reliever being effective. So it would be 1 minus the group that said the pain reliever was effective, and it gives you 0.25, which is the rest. And n is 112, the total. So when plugging it in, you have 0.75, because that's your p hat, plus or minus your z-score of 1.96 under the square root of p hat, 0.75, times q hat, 0.25, over this under 112. Now, when you do this part out first, you get 0.081 and plus 0.75. Now this right here, this equation will give you your confidence interval. So the confidence interval is 0.669 and 0.831. To get the 669, I did 0.75 minus 0.081, that gave you this. 0.75 plus 0.081 gave us 0.831. Now, you have to find the stat and the margin of error. So, this is your stat and margin of error. But if you want to check it, add these up, 0.669 plus 0.831, and that will give you, and then divide that. If you see over here, I did it, 0.669 plus 0.831 gives you 1.5. Divide that by 2, and that will give you this number. So we got that one correct. Now, to find your margin of error, you do your 0.75 minus your confidence interval numbers. 0.669, you get 0.081. 0.75 minus 0.831 gives you negative 0.8081, which is correct, plus or minus. Now, you write out your sentence explaining what this means. So, we are 95% confident that the proportion of people who got relief from painkiller A was between 70% and 83.1%. So now we're going to find the confidence interval for the people who thought medication B was effective. So we do the same exact layout, except we use Group B's numbers. So you'd use the same formula, same z-score, because we're still finding a 95%, because we're going to compare the two intervals. You do the same thing, 66 over 108, because 66 people in Group B thought the painkiller was effective out of the 108. Gives you 0.61. 1 minus 0.61 gives you the rest, which is 0.39 of the group. 39%, which is Q hat. N is 108 because that is how many people are in the group of Group B. Do this part out, you get 0.096 plus or minus 0.61, your P hat. So you do that out, you get your confidence interval, which is 0.514 and 0.706. Now, you already found your stat and your margin of error, but just to show you, if you want to check it, you do 0.514 plus 0.706 gives you 1.22. Now you take 1.22, divide that by 2, and you get 0.61. So we got that side right. So to figure out if you got your margin of error right, you do 0.61 minus 0.514, and that will give you 0.96. And then you do 0.61 minus 0.706, and it'll give you the same number. So we know that's right. Now, we have to write it out in a sentence. So we say, we are 95% confident that the proportion of people who got relief from painkiller B was between 51.4 and around the 0.706 to 71%.